for folks who are like, oh my god, math, trust me, I feel you. But here's something that's kind of fun. So I'd done this math before. It's this like crazy if statement. I don't even remember how I got here, and it's got to do these special things. So if I put in a debug float two values, we could take a look at what's happening here. Um, so what's happening is I have a direction up here, and I'm basically making a flow map, but I'm mapping these coordinates myself with math instead of using a texture. So I can use all the same things of these, but without needing a texture, which is fine. For what I was doing is I didn't like making flow maps anymore, and I just wanted to use a grayscale texture and change the direction myself. But I was using flow map math, so I was like, well, I just need to figure out how do I remap these colors into numbers. And so I somehow came up with this crazy if statement thing up here. And we can see what it does. If my direction is at 0.125, so this is assuming this is at 0. And then it goes 0 all the way around counterclockwise to 1. And so 0.125 is here because this is 0.25, this is 0.5, this is 0.75, right? Like 0.5 from 0 would be this. So 0.25 should be 50% green channel 0 on the red. So that's actually what I'm showing here, my debug value. Now if I point 0.25 on it, I should see 1 on the green. Yep. And if I add 1.125 because I don't remember the top one, the red should be at 0.5 and the green should be at 1. So that's kind of the funky thing is that your green is 100% when you're up here, and then your green goes down to 50 and down to 0. And it's the opposite with the red. With the red is 0 over here, and then it grows all the way to 1, and it's 1 on these values. So if I have my value at 0.5, it should be 1 on both of them, which is correct. And if I add that 0.125, that should get me 50% on the green because we're going back down and 1 on the red. And if I go back here, that shows exactly what this is. That's what exactly west looks like, right? 1 on the red, 50 on the green. Southwest, so that's 0.75. So now I only have 1 on the red, and then now this is the red going down. So if I go 0.75 plus 0.125, because I never remember these numbers, that will give me 0.5. And then again, if we go to 1 or 0, the value is 0. So that's what this math was doing. And I was like, okay, how do I remove the if statements? And I had honestly no idea how to make my new method. But I started to try to plot it out on like Desmos, where I was like, what do I need this to look like? So for instance, on the red channel is like 0 until 0.25, although I kind of mapped this wrong. And then when it starts, I start seeing from 0 to, or from 0.25 to 0.5, that's actually when I go from 0 to 1. So if I go here, you could see 0 to 0.25, there's no red. But if I go from 0.25 to zero point 0.5, I'm going from 0 to 1 on the red channel. And then here, when I'm at 0.5 to 0.75, I'm actually staying at 1. And then here I go from 1 to 0 on the red. So it's kind of making this shape here where it's like 0, then I start growing from 0 to 1, I stay at 1, then I start going down from 0 to 1, from 1 to 0 back when I hit 1 it should be 0 over here, which is down here. So I was like, okay, I understand what this is. This is basically a gradient. It's a gradient between here and here, and it's a gradient between like here and here, and then it's exactly 1 in the middle. And I was thinking to myself, well, I can make that with UVs. So I actually did do that. And if I just take this math here and in the multiply, um, we'll see if this is the right math. It might not be the right math. And I masked out one of the channels. I think I masked out green here to kind of show you what I was thinking and going through. And I need to reverse this. I just know this now. So I'm gonna just reverse this. But anyway, I knew I could make this graph with the math itself. The gradient, because that's what I'm good at, is I'm good at just looking at it and kind of understanding what I need the gradient to make. So this is how I made this gradient, right? So I take my mask is in the wrong direction, or I need 0 to start here. I shift it up 0.25 or subtracted 0.25, so I keep black. It's up by 0.25. And then I start my gradient here. But I actually need my gradient go from 0.25 to 5. That actually means that I need a multiple of 4 to get me there, and then I saturate it to clamp the ranges. And same with the making this little top feather part. I need this top feather is great. It starts up here. I just need to multiply by 4 so it goes from 0 to 1 in only 0.25 segments. Saturate that, multiply that. And guess what? That actually works. So taking that exact same way of making the gradient here actually was the math that I can use to put in this new number. So I'll just do it with I picked the wrong one. This is the y coordinate that we ended up mapping. And when this shows up, we'll hopefully see. So it should be 1 when we're at 0.25. And if I look at my coordinate system, yeah, green should be 1 on 0.25. Then if I use 0.5, it should still be 1. Now if I use 0.5 plus 0.6 or 0.125, so 0.625, it should actually be 0.5. Should be my value. Yeah. And if you look at that, that's exactly what that did. So this is what it should be. So then I just needed to invert some different areas and append those to get together, and I got exactly the same values. So we can see here, if I'm at 0.65, I should be 50% on the green and 100% on the red. And guess what? I'm 50% on the green, 100% on the red. And I could go to 0.75 and I should have nothing on the green and 100% on the red. And then I can add my 0.125, and that will then put 50% on the red, 0 on the green. And again, 0 would mean nothing over here. So fun fact, I just kind of looked at the graph and was like, I know that actually this is a gradient because I have 0 to 1, stays 1, goes back to 1. That's actually a gradient. So what I did is I made that gradient in Engine, and then that's what I needed to make. So that's a fun way that you can think about complicated algorithms you might not know how to figure out. Maybe plot them on graphs and turn them into gradients if you know what they need to look like. So let's the math is kind of scary, but also kind of fun if you can break it into the visuals that you need it to be.